คณะวิทย์ก็อยู่ตรงนี้แล้วนะครับผมคิดว่าในอนาคตเนี่ยต้องมีหลักสูตรแบบนี้ขึ้นในแต่ละคณะแล้วก็กระจายไปพื้นที่ด้วยนะครับอันนี้การอบรมเนี่ยผมคิดว่าไม่ใช่2 วันแล้วจบนะครับเราก็จะมีโครงการที่วันจันทร์ที่4เนี่ยผมจะไปเซ็นอธิการจะเซ็นMOUนะครับSDI แล้วก็อยู่ที่NC เนี่ยเราก็จะเป็นผู้สนับสนุนแล้วก็จะทำอย่างต่อเนื่องที่เราได้มา2 วันนี้เนี่ยก็คิดว่าเป็นจุดเริ่มต้นต่อไปเนี่ยเราก็จะมีการส่งอาจารย์เราจะไปอบรมที่สิงคโปร์ด้วยครับต่อจาก2 วันนี้นะครับก็จะคัดเลือกอาจารย์บางท่านที่ไปต่อไปเรียนต่อที่สิงคโปร์แล้วก็อาจารย์กลุ่มนี้เนี่ยก็จะกลับมาแล้วก็จะต้องทำแบบที่เขาทำกับเราเมื่อวานแต่คือต้องแก้ให้กับอาจารย์บุคลากรของเราก็1,200 คนที่ว่าทุกคนเนี่ยคงจะได้รับความรู้เพราะว่าถ้ามีหลักสูตรแล้วเนี่ยเราคงต้องมีการจัดการเรียนการสอนอาจารย์ทุกคนเนี่ยต้องรับทราบวิธีการจัดการเรียนการสอนซึ่งในอนาคตเนี่ยผมคงจะปรับเปลี่ยนไปแล้วก็คิดว่าในอนาคตเนี่ยเวลาก็จะตามไปถ้าเราไปต่อเราก็จะได้เปลี่ยนอะไรอื่นตอนนี้มีไม่กี่รายนะครับที่เริ่มเอาเรื่องของCDIO มาใช้ในการรักษาแล้วถ้าเราเริ่มก่อนเนี่ยเราก็จะได้เปลี่ยนเรารู้ก่อนในมหาวิทยาลัยเราก็จะได้เปลี่ยนนะครับก็ที่ว่าวันนี้ก็คงจะเป็นกิจกรรมที่เราจะได้รับความรู้อีกนะครับก็ขอให้เขาขอให้ทุกคนเริ่มก่อนนะครับสักครู่เนี่ยเราคงจะเริ่มแล้วก็คิดว่าตลอดวันนี้เนี่ยก็คงไม่เครียดนะครับเพราะเหมือนว่านะครับก็ว่าการจัดกิจกรรมเนี่ยก็คงสบายๆนะครับก็ขอให้ทุกคนช่วยกันนะครับเพื่อมหาวิทยาลัยนะครับ
The enhancing phase focus on raising professional standards beyond technical competence. So your students, the technical competence is acquired through part 1 of your skill set. Remember the 4 parts? The 4 parts, what are the 4 parts of the CDIO skill set? Part 1 is your disciplinary knowledge. That's where you gain your competence. Okay? That is your disciplinary knowledge. And part 2 to 3, part 2 to 4 consists of how many skill set? No, part 2, 3, 4, how many skill set in total? 16. Okay? Yeah, 16. This is the 16, part 2 is the personal skill set, interpersonal skill set, and the CDIO ability. Okay? So that the students are able to translate or turn theory into practice. So this whole phase is about that, okay, turning or enhancing the skill sets of the students. Okay, under this particular CDIO skill set, what do we need to do? I have here with me 3 bullets. The first one, how might we ensure that the graduates gain real-world experience? Okay, how do the student gain real-world experience? Which is very important. Remember, CDIO, the Tech 9 is ready to engineer. That means if you use CDIO framework to guide you in your curriculum planning, so you want the students, when they graduated, to be ready, okay, to serve the industry. So in order to do that, you should introduce real-world projects to them or real-world experiences. That's the first point. Okay, the second, how might we develop students' interpersonal skills? Okay, interpersonal skills to maintain cross-functional. Cross-functional, I mentioned that yesterday that, you have multidisciplinary projects. That means the projects consist of students from various disciplines. And within the projects, you must have cross-functional, different functions. Okay, so how do you develop these skills so that they're able to do that? And the last point is, how do you enable them to work collaboratively in a group? They must collaborate in a teamwork. Okay, so these are the 3 important things when you talk about enhancing. But again, this is not the end. You can also include sustainability, ethics, and so on. Okay, it's not limited to just these 3 points, because to support them, okay, in each of these 3 bullets here, to support them, you can bring in other skill set. Okay, so the skill set here, so other skill set to support how you run your multidisciplinary projects, how you run your cross-functional projects. Okay, so other skills will actually comes in. Okay, I thought because you have not gone to the first the first phase of the CDIO, I'll bring in this in. This is for design and build. I spoke about level of complexity. Okay, so this is how we have done in the first, second, and third year. When I talk about level of complexity, my first year is about building foundation. Okay, how do you build foundation? So you got to plan this very well. Okay, building foundation. So what do you need to do to build foundation in your students? That's the first stage. Okay, year 1. Then second year, you broaden the competency. What other skill set is missing? What other knowledge is missing? Because you want to get them ready to be able to do the third year projects. Okay, and then in the final year is your specialization. Because there's so many things to teach. So normally in our program, the way we design, I'm sure you practice the same thing. In the third year, we always have specialization. Sometimes we call option. That means we allow students to choose the area of interest. So normally we have about 4 to 5. You can't have too many, otherwise the students will get confused. So the specialization, you can either specialize it in robotics or maybe engineering system, okay, or management or computer engineering. So in the final year we have specialization, and students can choose based on their area of interest. Okay, so in the first year, I mentioned that we must have introduction to engineering. Then second year we have design and build. In fact, we have design thinking as well in the form of the title is called SIP, Social Innovation Projects. So one of the modules in the second year, okay, see the first year here is introduction to engineering. Second year we have a design and build projects, as well as in order to broaden the competency, we have introduced what they call SIP, Social Innovation Projects. In these particular modules, the students are taught design thinking skills. Okay, and the projects they do are mainly community-centered projects. And this is a compulsory module for all students in the second year. It's a 30 hours module, compulsory. So every students are trained with design thinking skills, so that when they go to the third year, okay, of their course of study, they are more or less well equipped to tackle any projects, hopefully, yeah, to tackle any projects. So in the first year, we concentrate on, okay, this little thing, I don't know whether you can see or not. Okay, the first one is the activities. Okay, these activities. Activities is either CDIO. For our case, CDIO, in the first year, we focus on I and O, implement, operates. The students are not required to conceive and design. We give them an idea, we actually design for them, because we're training them the foundation skills of building products. Okay, so our emphasis is on I and O. And then the structure is very structured, because everybody has the same drawing. Everybody make the parts. The only thing they have to focus on is how to produce the parts, okay, with accuracy. That is the emphasis. And then we teach them all the skill set in order to produce the products. So if it's mechanical engineering, then we teach them machining skill set. If it's electrical engineering, it will be a different kind of skill set. Could be soldering or producing printed circuit board and so on. So it depends on the discipline. So the skill set you choose to teach a student depends on the discipline. And then the third one will be the solution. So normally for the first year, the student know the solution. Okay, it's the reverse of the final year. The final year, normally solution is not given. Okay, and then the team. This is usually small team. They work in team. In the final year, I know that in university, normally the student do alone, okay, individual projects. But for us, we still practice teamwork throughout, okay, because the project that we do are quite, some of the projects are quite big, quite massive, and require a lot of manpower to do it, okay. And then the duration. You want to talk to the hello? You want to talk to the group? Yes. Yeah. Rather than you going round, it's disturbing me. I'm very distracted.
Sorry ผมจะอธิบายเรื่องหลักสูตรเฉยๆนะครับว่าหลักสูตรนี้เป็นหลักสูตรปวสนะครับคือไม่ใช่หลักสูตรปริญญาตรีนะครับคือสิงคโปร์โพลีสอนเฉพาะปวสหลักสูตรที่เห็น1 2 3เนี่ยก็คือเป็นปวส3 ปีซึ่งรับจากเด็กมบ้านเราก็คือม4ม5เหมือนปวส4 ปีของเราเมื่อก่อนที่ราชมงคลเคยมีถ้าอาจารย์ท่านไหนมีอายุหน่อยก็จะ เคยเห็นนะครับเป็นปวส4 ปีซึ่งรับเด็กจบม4ขึ้นไปมาเรียนนะครับเพราะฉะนั้นปวสของเขาก็จะคล้ายๆกันก็คือจบเกรด10เกรด11มาเรียนต่ออีก3 ปีครับ I explain the curriculum because most of them don't know the background of Singapore Poly.
Oh, you should have told me. I can explain. Do you know the background?
Yes, I know.
Are you sure?
Yes.
What did you tell them?
This is a 3 years diploma.
Okay.
After grade 10, grade 11, right?
Oh, so you went around every table to tell them this?
Yes.
You should have told me. I can tell them. Okay, he should have asked me to tell you, right? Okay, our students actually finish the O level. Okay, after O level, that means after 10 years of studies, they come to us. Then after us, we have, actually we link up with university. They can continue to go to university for 2 more years. For some courses, especially engineering, we get exemption. So we work very closely with the university. So our course is actually a 3 years course. But most of our students, more than 50%, continue to do a degree course. Okay, we used to conduct degree courses in the poly, but through collaboration, because we are not allowed to issue degrees. So in collaboration with university, okay, we work very closely. Okay, but those universities who don't come to Singapore, we actually, most of the time we send our syllabus to the university, so we have a collaboration so that our student can articulate directly into the last 2 years of the course. Okay, so for our course, usually it's 3 years. Now for university, normally it's 4 years. So what I'm sharing with you is 3 years. Okay, what you could do is you expand from here. Most important thing is you understand the process, understand what is needed, then from there you can modify. Okay, so I thought I'd share with you this first before I jump into multidisciplinary projects. Because this is a common structure, but this structure has since changed. When you introduce multidisciplinary projects, the structure has changed, which I will share more. So some of the courses it actually run across. That means students taking like the engineering academy, they take the same modules. So I will explain that. But most important of all, you must understand how this works. Okay, how I actually increase the level of complexity. What needs to be introduced. It's the same whether it's 3 years or 4 years. If it's 4 years, then you say, okay, at the end of the day, the 3rd year, this is what I want my student to do. So what skill set should I impart to the students? What skill set must the student learn? Then you plan accordingly. Okay? So in this particular case, the skill set that we have chosen, okay, is communication skill and general education. So this is a common skill set that runs for 2 years. Remember, year 1, year 2, year 1 especially is foundation course. Okay, so based on this diagram, the duration is days. Now, if anything you don't understand, please raise your hand and ask me. Okay, rather than our gentleman here jumping from one table to another to explain, just let me explain. Okay, just raise your hand. Don't worry about interrupting. I'd rather that I explain to you. Okay, so the 2nd year, if you notice, is changed. 2nd year, because in the 1st year, we have already teach them the skill of implementing and operating. So in the 2nd year, we try to introduce CD, conceive and design. That's why we introduce design thinking. So we thought that, okay, now they understand how the product is made. So I'm going to teach them how to conceive conceive ideas and design the products. Remember, first year we did it for them, but second year they have to learn how to do that. So that finally, when they go to the third year, they practice. Because in the third year, we only give them one title, okay? Design an automated, say, IC chip assembly machine. Only one title. Then they have to go and do research, explore. But how are they going to do that? They can't do it unless you prepare them. Okay? So in the final year, you leave them alone, you give them a topic, they should be able to continue to do. And I'm sure it's the same for your university. Okay? But the way we do it is because of CDIO, we put it into a proper format, a proper framework to guide us into what needs to be done. Okay? So if you see the time, normally, again, the first year, second year, the structure is very structured. But in the third year, there's no structure. It's up to the students to develop. Okay? And then the duration. First year is normally the projects. You take days to produce. Second year is weeks. But in the final year, normally it takes a whole semester or a whole year to produce the projects. So this is how we progress. Okay? How we increase the level of complexity for any design and build projects. Okay? Now, I'm going to show you, I promise to show you this video. This is done, remember I said 2004 we were members, 2006, Chasimo, myself and two others, we went to Montreal, December. So we're given exactly 1 year, but it's actually very long. But those days, like I mentioned, there's nothing to refer to. So we have to work very hard on our own. So this is the very first projects, the CDIO projects, that we actually ask students to do, and I'm going to show you a video so that you know what I'm talking about. Okay, sit back and watch. I call it the CDIO raising concept. Look at the faces of the students. Okay, this project was done in April 2008 because we wanted to show very quickly. I mentioned the buy-in. because CDIO was very new then, so we needed to buy in from staff. So we invited the principal and everybody from all the whole poly to witness this. And we was quite surprised at the quality of books produced by students. Okay, now a lot of people ask, if you do CDIO, oh, we don't have budget, we don't have money. I did not spend any money here. Why? Because this track here, because we knew we were going to do at the end of 2006, we then built it in as a final year projects. So the students, their final year projects was to build a track. So it became part of their projects. So have you noticed it's managed by students, not managed by a technician or who? Okay, so these students, they built the track, so it was ready. So I didn't spend any money because they will have to build the projects anyway. Okay, so this is one way. So that means to say, you look at your existing things, you don't have to keep asking for money, but look at your existing activities and see how you can change that. Okay, I'm going to show you the car, and then you tell me what this is made of. Okay, you look at the students' faces, they're also excited. Now, what material do you think these cars are made from? Anybody can make a guess? What material? Huh? Polypropylene. Oh. Okay, polypropylene. What other things? Fiber. I said no money, you know. Money, fiber is going to be very expensive. What? Carbon fiber. Carbon fiber. Paper. Paper. Okay. Paper, would it be hard enough? The weight. Because it's by gravity. There's no motor. You see, you can introduce something like that. There's no motor. It's by gravity. So gravity, that means I don't have to spend money on developing motors. Okay. Anybody else? You still haven't got the right material. Huh? Tin. Tin. Okay. Remember, I did not spend much money. Okay. What else? You still haven't got it. Plastic. What kind of plastic? Have you heard of high density foam? High density foam, blue color or white color, is foam. One piece, maybe double the size of this. One piece with this same size. Okay, this size $10. We cut it into 4 pieces. Each student has 1 piece. Each student is given 1 piece, 1/4 of this size, to make the car. That's all. Okay? Now, in the past, the students were asked, because this introduction to engineering was converted from workshop practices. So, have you noticed the chassis at the bottom here? There are 2 parts. Okay, this is an integration. The top part is taught in one module. The bottom is taught in another module. So, the top part is taught in design modules. Okay, so the student design and they make all this by themselves. And then the bottom is the aluminium, mild steel chassis. Because in the past, for the workshop practice, they were machining things which they threw away. You see? So I'm using what they have given because materials are already provided. The only money I spend is this. But it's not really true because in design, we were asking them to use plaster of Paris to build models. So instead of using plaster of Paris, I think it's more expensive. Okay, I just use high density foam. And they're all made from high density foam. Okay, now, how, as lecturers, how are you going to supervise this sort of projects? How? We don't know what to do, right? I happen to be teaching this subject as well. So how am I? I'm not ready. I don't know how to do this. So what happened? All of us have to go for 3 days course. I attended the course on how to make these cars. Okay, so it's high density foam. We were taught how to cut it, how to file it, and then how to apply to harden it. We apply plaster of Paris, then we put primer, we put paint. But the students were more creative. I dare not show you the car I produced. It's very ugly. Okay, this car produced by them is, they were awarded, there are 2 prizes. The most innovative cars. Okay, and some of the cars are so nicely painted. So we asked them, how do you manage to get such nicely painted car? They were very creative. They went across the causeway to Malaysia and get it painted. Okay, because Malaysia is cheaper. So some of the students took the trouble to go and get it painted. But we don't pay for their paint work. So one rule I have imposed, we don't provide any paint, because the moment you provide paint, there'll be a lot of wastage. But if they have to pay, then there will not be wastage. Now, there are 4 or 5 people in the group. If they split up, it's quite minimal. Each one pay less than $10 to get it painted. Okay, so we don't provide the paint. We only provide the raw material. Okay, so this is our first CDIO projects. So you put it in action, everybody, you see the students' faces, they're all very excited. So you make the subject very exciting. Okay, so instead of machining something which is not useful, now they're machining something which they can see in action, you know. So to make it more exciting, we introduced competition. So that's why this was one of the first time, I think it's the first time we introduced competition. But after that, this mode of delivery has been, most of the time we are using this mode of delivery now. Okay, get them to do the products and they have a challenge so that they're very proud of their work. You see their faces? Okay, so this is the first project. But of course, subsequently there are many, many more. But since then, we don't do this project anymore. We go to more difficult projects. We increase the level of complexity. So we introduce electronics. So now it's been replaced by the catapult, you know. So 2 armies fighting against each other. So this is how we progress. After 10 years, we need to change. Yeah? Okay, so because I thought I better share with you how we started, then how we moved towards multidisciplinary projects. Now, multidisciplinary projects can be introduced in many ways. Okay, so I'm going to share with you, yes, the previous slides. Yeah, I will give it to you. Because yesterday when I did a hand count, I realized that most of you have not done the first part, so.
Could you please turn back to the previous slides,
The
please?
previous slides. This one?
Yes, this one.
Okay.
I see that you always set to be the small team for 3 years. Do you have the subject that you set it to be the individual subject?
Individual projects?
Yep.
We don't have individual projects.
So everyone should be...
Normally for projects, because our project is quite complex. So one student cannot do it.
Okay.
Minimum 2 students.
Okay.
Because of the nature of our projects. Don't forget, a lot of our projects like multidisciplinary, real-world projects, you can't have one person working on it. Okay? So, but in the team, we are also, what are the skills that we are trying to teach them? Teamwork, communication, what else? Critical thinking, creative thinking. See, in one project, I've introduced so many CDIO skill sets. Okay? In one project. So all these are built in. But, because in the part 1 of the CDIO, we actually go through in details how you actually align the learning outcome and so on. Okay? So any more questions? No questions, huh? Yeah. How many students? There are about 20. For engineering, it's about 20. So all our equipment, the computer, everything is 20. But I think School of Business is about 30. 30, yeah? School of Business, because the engineering, we need a lot of equipment. So it's about 20. I think it's the same for yours. No? 40. Okay. Our tutorial, our lab work is always 20. Okay? Okay, multidisciplinary. I'm going to share with you a few ways how this multidisciplinary project has been organized. Okay? Now, before any course, okay, I will share with you. This is from the electrical engineering. Okay? So before they do anything, they have to find out. Okay? Like School of... Okay, any question you want to ask? Okay, In the School of Electrical and Electronic Engineering, okay, before they start reviewing the course, they ask themselves, which are the sector the students are likely to go into? Okay. Yesterday we did the nature, the future of work. But here we are talking about the sector because we already, this is a course which is ongoing. So we ask which are the sector. So there are a few sectors, but I pick up one sector just to share with you. Okay. In each sector, this is the power engineering and sustainable energy sector. We talk about the career. What's our career? The future of work. Okay, what's our career? And then we talk about, in order to fulfill this career, what sort of skill set you need to train them. Okay, so for these particular schools, they've done it for 6 sectors. Okay, this is only an example of one sector. So you talk about what sort of career, then you talk about what skill set you need to impart to the students so that they're ready. Okay, then you talk about which are the company most likely to employ your students under this particular sector. And then after that, you talk about what are the technology trend. Okay, all sound familiar? Technology trend. Okay, the kind of job, future of work. Okay, the skill set and the company to support. So what you have done yesterday, but we put it into a different format, but it's the same. Okay. Then after that, we say, okay, these are the skill set. I highlighted the skill set. So these are the skill set. This is done. We map against the competency. So the competency map against CDIO skill set. So these are the skill set, okay, that we need to infuse into our curriculum to prepare our students. So based on this, we then go on to say, what are the type of projects? Now remember, you know these are the skill set. There are many ways of teaching the students. Okay, so one of the way, if you are not ready, let me know. Okay, one of the way is through what we call the engineering academy. Okay, now this engineering academy is formed between 2 schools, School of Mechanical Engineering, School of Electrical and Electronic Engineering. So every year they ask the students, about 20 to 40 students, select this particular program. Okay, now this program is in addition to their diplomas. That means they come from these 2 diplomas, diploma in Electrical and Electronic Engineering, and then Mechanical Engineering, and the diploma in Aerospace and Aeronautical Engineering. So altogether 4 programs, but I was told that they have included more discipline now, more schools. So what happened is, for this engineering academy, the students will replace one of their module in their own diploma to do this particular module. Okay, and we call this module Nature-Inspired Design. Okay, this is one way of doing multidisciplinary. So that means to say that the 40 students, they will replace one of the modules in their normal diploma to do these particular modules under the engineering academy. Okay, so this module is conducted in the year 1, first semester. And we have 3 staff teaching electronics. So that means in order to service this particular module, even the staff are multidisciplinary. Okay, the staff came from electronics and mechanical and design discipline. Okay, the staff came from 3 disciplines. Oh, it's gone. Okay, then emphasis here is on design thinking to support the CDIO. Okay, this is one way. So multidisciplinary projects doesn't mean that you have the students come from different disciplines, but here the staff also come from different disciplines, so that the students are well prepared to do this. So what do we do? So can you see any similarity? So nature inspired. Say you look at a crab, okay? Then you do this finger. This is a, what is that? It's a gripping. Usually used in robotics, right? In robots, the gripping, they call it gripping hand. Okay, so the gripping hand is designed, and the design is inspired by the crab. That's why you call nature-inspired design. Of course, there are more. Okay, now in this particular program, in order to do this, so now you know that, okay, I'm going to have multidisciplinary projects, but my emphasis is on nature-inspired design. If you Google, okay, you'll find that so many people are also doing this sort of design, nature-inspired. There's a lot of literature out in the internet. Huh? Okay, now what is the focus area? The focus area, that means we want students to do this. What are the focus area? Autonomy. That means you want them to be able to do on their own. Okay? And you want them to integrate electrical, mechanical, and design. Okay? And it's a maker. Okay, let's talk about communication first. Communication. You want them to be able to communicate between the students from a different department, staff from the different department as well. Okay, different schools. And one very important thing is this, the maker culture. If you walk into Singapore Polytechnic, you'll find there's a lot of 3D printing machine. Because now 3D printing machine is very, very affordable. Okay, so in most lab we'll provide, so we want them to have this maker culture. It means whatever you want to make, you can very quickly produce using the 3D printing, to see the products. You can't do that in the past. I remember the first rapid prototyping machine, which I bought way back in the 1990s, it cost me $60,000 to buy a FDM, field deposition modeling rapid prototyping machine. And then you need very skilled technician to operate the machine. Now the 3D printer, I think it's about $2,000-$3,000. And you can produce the part very quickly. Okay, the whole intention is to see the parts that you've designed, what it looks like. Okay, so we have this maker culture. Even in the library, in our library, there is 3D printing. We call it the maker space, which will allow students to also test out their ideas. Okay, so this maker culture is being infused so that whenever they make anything, they have this, culture that, okay, I can test it out. And I can test it out very quickly using the 3D printer. And we also have a fab lab, which students can go in anytime they want to test out their ideas. Okay, so these are the 5 focus areas. Sorry, 4, 1, 2, 3, 4, that we want to instill in the students for these particular modules. Okay, so if you look at how it's done, first they have the specification. Now, when they're conceiving and designing, we call this the divergent phase. Because while you're conceiving and designing, you can come up with a lot of ideas. Okay, we engineers, we know, right? Or those non-engineers, even if you want to conceive anything, you always generate a lot of ideas. Then after that, you decide which one you want to do, then you design it. Okay, then once you have chosen your design, you then converge it, okay, to implement and operate. So this is the phase that the student have to go through, the CDIO. Okay, conceive, design is a divergence because you got to generate a lot of ideas, and then once you've generated your ideas, you've selected your ideas, you then converge it into the selected design, and then from there you implement, you make it, and you test it. Okay, the coverage. In order to do this particular module, what are the things that you need to cover to prepare the students? Okay, they have to have the design elements, mechanical subjects, and electrical subjects. Remember the first slide to show you, there are 3, the lectures come from 3 disciplines. Okay, each one in charge of one part. And then, I won't go through the details, but you can look into the subjects that they teach for each one of these. Okay, this will give you an indication and idea. So if you are interested in producing nature-inspired projects, these are the guide. For mechanical, we got to teach them CAD, 2D, 3D. Then we got to teach them mechanism because the thing have to move. Okay, so in mechanism and mechanical components, we teach them gear, spring, and so on. So these are the subjects. So that means to say you want to prepare them to do nature-inspired projects. What do you need to prepare them? So these are the things that you need to prepare them. Okay? Okay, now, when the students, so now you have already designed your curriculum. You know what you need to teach the students. Now, from a student's point of view, what must you do? You tell the students, okay, this is the projects. Okay, give them some examples, like a crab. You can also have robotic crab. Okay, this is actually mini AGVs, no? Automatic guided vehicles. Okay, these are very mini one. Huh? And then you have the snakes. So you can ask them to design something like a snake. So what is this used for? The snake robot. Anybody tell me? What's the snake robot used for? What's that? Help people in problem. Next skill, what is that? Oh, okay, very interesting. Because I was thinking of only one. Okay, he gave me a very rescue robot. You see, I know that the first snake robot was used in car assembly. You know car assembly? Because certain places you cannot reach, so you use the snake robot assembled inside the car. But he said that it can use as rescue robot. So that means in disaster places where human cannot reach, the robot can actually reach. You can put a vision system. You can put a vision system, and then you use the snake movement to find out whether anybody is in the rebels or not. Yeah. Okay. Any other example? The cars, rescue robot. What else? I mean, it's up to you what you want to use. But the most important of all is you are actually taking the ideas from the snake to move your robot, like the way the snake moves. Okay? Okay, I want to show you this little video. This is a nature-inspired next generation flying robot design. Just see a little clip on this.
It is very important to be curious about biology for engineers and have the creative process that actually inspires novel designs, novel flying robots. If you look at small flying vehicles, small flying robots, such as nano quadcopters, or we have one here flying in the lab. Actually, the seat so I can catch it if I'm... Okay. So something like this weighs only a few grams, and it needs very lightweight sensors. And there we can take inspiration from biology, from flies or bees, that use only their visual system to avoid obstacles, for example. So this is a very powerful example of using visual sensors to avoid obstacles on quadcopters and do landing maneuvers and controlled flight. So swarming is a very powerful means of accomplishing complex tasks with small, cheap and simple systems. How nature does that is in examples of flocking birds or schools of fish, is that each fish or each bird uses very simple navigation principles or ways or sensors as well. And like this, together as a collective systems, they're able to provide very complex behaviors. So doing the same with robots can allow us to make very complex tasks.
Okay, so you take a lot of ideas from nature, how they see, how they sense, and you build it in.
So I think the next step for the...
Okay, now, I always have this thought in mind. You know, there's a lot of war zone with a lot of mines on the floor, and a lot of people get injured. So I was always thinking, why don't somebody invent a robot, you know, that can actually detect where the mines are? You know, that's the only way, because you cannot get human to go, because the moment you step on it, the whole thing will explode. So why don't someone design something? I mean, that's the thought that went to my mind. You know, something that flies and you can actually sense and see where the mines are hidden. And then you know exactly where you can actually get rid of it. Huh? Maybe think about it as the next project. Okay. So for the students, we show them some videos. Because for lecture point of view, this is what you plan. So now you give it to the students. Okay? You tell the students, show them a video and say, okay, I want you to design something like that. Then you say, give them a brief. Say, okay, I want you to build something that jumps, something that crawls, something that throws, something that swims. It's up to you. Okay? So you don't have to choose all. You only can choose one of those. Or something that grips, like the crab. Okay, something that flies is like what you see, the flying robot. And something move unconventionally and so on. So you have to choose a theme. okay, for the students. So every year you can change so that you don't have to give them the same thing every year. So maybe this year something that crawls, next year something that throw, okay, something that swim. I think something that swim, they've done a sea monster. Okay, so this is the learning experience that you want to give to the students. So for this particular module, you look at what is needed. You need the design studios, design engineering studios for carrying out the activities, then the project work, and there's also a seminar. So at the end, the students actually present their work. Okay, we normally try to make students present their work because when they need to present, they're more serious and they will take pride in their work. And finally, of course, you're going to mark them. Okay, the type assessment. Because I know you will ask me, so how are you going to assess the students? Are they in teamwork and so on? Okay, so for the assessment, we actually group into two categories, the individual and the group work. So the different colors depict the different type of grading. So the darker orange is the individual work. So for individual work, research process and journals, presentation, so you have to decide. Because if it's a teamwork, our practice is never try to give only team marks. Try to make some of the component individual. Otherwise, you will have a lot of Indian chief. One person working, the rest all looking. Okay? So we are very conscious again when it comes to assessment to make sure that the assessment is accurate and fair. Very important, fairness. Okay, now what do the students do? In order to prepare them, okay, I'm going to talk more about this. The subsequent projects, I'll go very quickly. So to prepare them, we spent a day, we actually took them to the zoo, okay, during the conceiving parts. So the students who do these projects, they do these more particular modules, nature-inspired projects, we spend a day, we bring them to the zoo to observe. Then they choose the animals that they want to follow. Okay, then once they come back, okay, they then start to make prototype, very simple prototype. Remember, CD is part of design thinking. So they start to make these prototypes. Then once they've confirmed on the prototypes, they then start to implement, start to build it. And finally, they operate it. Okay, so these are the 4 phases, CDIO, that the student will have to go through. Okay, so I'll share with you the lecturer's preparation part. Then now when you impart it to the students, what you need to do. Okay, you got to prepare all this. Okay. Any question on the first type of multidisciplinary projects? Any questions? No? Okay, the second one, engineering invention. Again, these modules, okay, we concentrate more on the C and D part to get them to understand what are the inventions out there in the market and its ancient invention. Okay, again, these particular projects, there are 4 disciplines. Okay, mechanical, electrical, chemical, life science, and have you noticed this particular one, maths and science? What is maths and science doing there? This one has got 4 schools. What are they doing there? Okay, so you plan. Okay, I want them to get involved because what the students need to do is they have to go to the internet. They have to do research to find out what are the past inventions. Okay. Then before I go on to that, the focus area again is the same: autonomy, integration, makers, culture, and communication. So what we want the students to do, this is the second year. Just now, this is also under Engineering Academy. So the first year is the nature-inspired project. Second year, we wanted to look at past invention. So what the students need to do is to study the work of ancient engineers in Asia. Okay, what they have done. So now we are teaching them. What skill are we teaching them? What skill are we teaching them? Research skills. Okay, to find out what has been done before. How can you take some of these practices for modern engineering, ancient to modern engineering? Okay, then what they need to do now. The question: why maths and science are involved? Because for this particular project, the students must develop mathematical models of their design and do a simulation. Okay, now whether you want to involve, that's why you need to plan. If you want them to do a mathematical model, then you got to bring in the maths and science people so that they can advise, because we will not know how to develop mathematical models. the maths and science lecturer will know how to do it. Okay, so we get the involvement. Okay, so right now they can help you to design your curriculum. Like I always say, yesterday when some of you were doing the exercises and you were doing alone, then I always say go back to your group and discuss, because the more you discuss in the team, you can get more ideas. Okay, remember today's technology, today's projects, it's very difficult to work on your own. You've got to work in the team. And then we also want them to use modern tools to replicate. You see, what we want them to do is to practice on research, the research skills, and then also to ask them to take some ancient invention and put it into the modern context. How do you modernize it? Okay, and then lastly, so the primary objective is to instill research skills. So the first one, we actually have nature-inspired projects to teach them C and D, how you conceive ideas. Now we teach them how to do research. So you must have an end in mind, what you want your student to do. So you plan it out accordingly. Okay, so these are the syllabus that they need to do. I'll leave it for you to reference. And these are the topics for the particular modules. Okay, let's look at the maths and science. What do they need to do in order to prepare them? Triangle law of vector addition, relative velocity and frame of reference, dependent and independent variables and cause and effect relationship. So you choose the topics, okay, so that to prepare the students to be able to do this mathematical model that you want them to do. So that means the topic is very important. Okay, now this is a new way of teaching. That means I'm going to teach the students. I'm not going to teach them like individual discipline. Okay, we actually use this method in the last few years, last couple of years. So this is our new way of teaching. Okay, you have a products, and then you see one need to support the products. So now the students, one very important thing they learn. What is it? Normally in the past you teach the discipline silo. Okay, so one of the complaints, the student cannot see the relationship between the modules. But here they can see very clearly, right? Okay, they know what the math is used for. In the past when you do mathematics, that's it, you don't know how to apply. But now I'm teaching them how to apply the maths. So they learn maths, they know how to apply. Okay, they learn mechanical, they learn electrical, they know how to apply. So because it's all integrated. So it is multidisciplinary as well as integration. So now students can appreciate more. So when they learn the modules, they will learn it now with a view in mind, okay, this is the objectives. I have to understand this so that I'm able to apply this. So I think it's a more meaningful way of teaching. Okay? And then of course, in the schedule, now, the planning part is always the most difficult. So when you plan, because there are 4 disciplines, so you got to be very careful, because I've done this before. So when you plan, you got to make sure first you plan your phases, the project process first. What you want to do, the student to do, okay, for each phase. Then you ask yourself the question. For phase 1, the project proposal, what knowledge do they need to know? Okay, so you go back to this. These are the knowledge, right? So what do they need to know to enable them to do this project proposal? So that means the way you schedule the teaching of this is also very important. Okay, so there's a lot of challenges here. It's not only about doing the projects, but you must also make sure at every phase of the projects, okay, at every phase of this project, what needs to be taught so that they are ready to do this phase. And then it goes on. Okay, second phase, what needs to be taught in order to do these particular projects. Okay, so you got to plan all the phases and then your subjects, the topics to support this. It's very interesting because I've done this 10 years ago. It's very interesting but it's very mind-boggling because we have to get the timetabling people in because they need to help us to plan as well, timetabling, provision of classes, the time, make sure the time is free for these students, and then we get all the different lecturers in, we get the supporting staff in as well because they need to support in the students' projects. Okay, so you got to get a lot of people in the meeting to find out what needs to be done, and most of the time people forget about supporting staff, but they are very important because they are the ones who's going to help you okay, to help the students realize their projects. So all these people got to be in. So, but it can be very interesting, okay? So you need to discuss and then come out to decide what needs to be taught, when you need to do it, where do you need to bring the students, which workspace, and so on. Okay, it's not just planning the projects. Everything got to be in, okay? So this will give you an indication. Okay, then again, distribution by discipline. How many percent of the modules do you want to teach them for this particular module called engineering invention? Okay, 20% maths, 30% maths because you are asking them to produce a mathematical model, and then 20% on electrical, CLS is 20%, and then 30% on mechanical because they need to build. Okay, so you make a decision on that as well. And this is the student project phase. Sorry, this is the student project phase. The first phase is on the research. Then they conceptualize the design, analysis and testing because we are doing a simulation. So it's on analysis and testing. And then finally, you do an integration and you build a prototype. Okay, but the testing here is on producing of a mathematical models. These are some of the work done by the students. Okay, I give it to you for use as reference. Okay, any question on this? So you see, there's a lot of difference between the first multidisciplinary and this one. Okay, so whatever you do, always involve the staff, supporting staff, and everything got to be spelled out, timetabling as well. Yeah. A chemical life science. CLS stands for chemical life science. That's where Chasimo came from. Okay? Chemical life science. Mr. Cha comes from that school. In fact, here three of us, although we are doing CDIO, we all come from different schools. I came from mechanical and aeronautical. Mr. Lee there from School of Business and Accountancy, and Mr. Chasimo from School of Life. So you see, CDIO is not only specific to engineers, even the facility that come from multidisciplinary. Okay? So because when we plan, we also take into consideration of all the discipline. Any questions on these second methods? Yeah. Sorry.
How that we can know the percentage of the discipline that used in the project?
The presentation of the projects?
The percentage, 20, 30.
Oh.
How did I know?
No. This is distribution by discipline.
By discipline.
That means to say, in order to do this engineering invention, how many percentage of the discipline that you want to teach the students? This one has nothing to do with assessment yet.
So they can focus by topic.
When you plan. So the topics are here.
Okay.
These are the topics.
Oh, they're the topics. Okay.
So this topic will be like 20%, 30%.
Okay.
The whole module. How much goes to mechanical? How much goes to electrical? Okay.
Thank you.
This one is not assessment. Yeah. The mic. Okay.
Hello. In each year, student decides a lot of innovation. So at the end of the year, what do you do with those kind of invention?
Okay. I've been asked this question many times. We do not patent the products. Okay. Most of the time, unless it's a company projects. Then sometimes when we do company projects, we are not allowed to show because the IP belongs to the company. Okay? So sometimes certain projects that we do is such a waste because we did such wonderful projects, we are not allowed to show because companies say we can't show. But for most of the projects, we don't patent student projects unless, I think Mr. Lee Chonghua, under the LWC they patent, right? Because it's specific to company. Yeah? He's talking about patent. Unless the because we have another what call it?
We have collaboration
with the companies.
Under this consortium called
LWC.
Well Collaboratives. This one we work with many companies. We work with Boeing, the biggest airplane makers in the world. We work with P&G, consumer products, your Colgate, your wash. Okay, so we do a lot of developmental work with them, and because that patent, they sponsor the money for the project, so the patent belongs to them, to the company. But the students and the professors' name who are involved will be named as well. So they get the honor that the patent, they put who created this product, but the patent belongs to the company.
But so far in my experience with the teaching factory, which I'm in charge of, we only patented, I think, one product, which is the faucet used for ladies. So far, only one, because it's very unique. But most of the time, we do not patent the products. But, however, having said that, sometimes when we design, if it's sponsored by the company, if they allow us to exhibit, yes, because they pay for all the fabrication. But sometimes we make the products with inputs from company. Okay, so when the product is successful, the company can actually buy the products. Okay, we have this mode. I mean, a lot of people ask me, but you invent so many things, why don't you patent? But unless it's company projects, otherwise, okay. Now, this is the second type. I'll only go on to the third, then I will stop. Is it 10 o'clock already? No, it's 9 o'clock only, yeah? Okay. I'm looking at Singapore time, sorry. Okay, now the third one, this is another multidisciplinary project, where you call engineering and design. So you combine engineering system and you combine design. Okay, I have actually done this in the second year of my CDIO program. Okay, now this is a very painful process. When I introduced this in 2009, okay, I had to convince so many lecturers, because lecturers who are teaching engineering design, engineering system, the gears and so on, and those who are teaching computer-aided design, they don't understand each other. Okay, so we actually strip the two modules apart and we actually integrate it. So we say that the way to teach students, when you teach them engineering system, they must also know how to draw to support. I mean, that is our view. Okay, so of course, lecturers with engineering engineering system and engineering design is completely different. They're two different fields. Of course, they're not going to agree. So how do you think I overcome this problem? Q&A. How do you think? I ask you a question or you ask me a question? Huh? So how do you think I overcome this problem? I have one group of lecturers, about 6 of them, and then another 6, altogether about 10 or 12 lecturers. Both these different disciplines. I say, no, you must combine this and call it, instead of engineering and design, you call it design and build. So the name is changed. So how do I convince them to accept this idea? Anybody? Q&A. I ask you the question. Anybody has any ideas? It was very tough. So I'm sharing with you some of the difficulties we face. Anyone? Okay, how?
So it is my opinion. I think first to change the name, to not make each of their fields belong to each of them.
Yes.
And then I guess the next step would be put the final task as a goal and make them realize that if both of their knowledge, if they put together, how valuable it's going to build to the things as a final project.
Yes, very good point. This is exactly what I did, okay? I changed, but this is another module. This is new, so they are not aware, so it's okay. But when you have to take existing module, her point is very good. I changed the name to design and build. You can't recognize whether it's engineering system or engineering design. Okay? Then, but you have lectures from 2 groups. And they say they don't know. How are you going to make them teach the same thing? Anybody? First point, very good. Change the name, which I did. Okay. Second thing, how do you convince the lecturer that they are capable to teach both sections when they are only capable of teaching one? How? Anybody? I ask you a question. How? Anybody? I call what I call shadow teaching. So for one whole year, because our program is 1 semester, 1 year, 2 semester, I make 2 lecturers do 1 subjects. So that means when it comes to engineering design, the lecturer will teach. When it comes to engineering system, another lecturer will teach. So what happened? They learn. After 1 year, they are on their own. So I do this cross-learning. I don't have to send them for training. No money spent. Again, I always don't like to spend money. Of course, I spend money on myself, yes. But, okay, so no money spent because they train each other. Okay, so for 1 year, I call this the shadow. Of course, the timetabling will make noise. Oh, but then you're allocating 2 staff to 1 module. I said, never mind, only for 1 year. I save you money on training. Okay, so shadow teaching. So when it comes to part A will teach. When it comes to part B will teach. So they learn from each other. So after 1 year, if they tell me they can't teach, I tell you I'll be in trouble. But fortunately, after 1 year, they all can teach. They all go on their own. Okay, so this is one way of training the lecturers. Don't have to spend money to send them for outside training. Just shadow teaching. Okay, so after 1 year, everybody is very comfortable. They can teach both. So they are left on their own to teach the whole design and build module 2. Okay, this is how we do it. Okay, any questions? But of course, this is a new module, so it's different. It's easier to implement. And this particular module is taken by 1, 2, 3, 4, 5, 6, 7 diplomas. Okay, so 7 diplomas. You see, there are 7 different disciplines who is actually taken these modules. Engineering, but this design is slightly different. This is real design and engineering. Okay, so again, you look at the schedule. Every part of the way, very important. You plan every part of the way, every section, every week. You must plan what to teach them, what do they need to deliver. So you got to be very clear what, like the lady over there said, you must be very clear what you want the students to be able to do, the end in mind. Then you plan it accordingly. Okay, so the emphasis here, now the pedagogy here is slightly different. The pedagogy, we use a lot of this is the teaching and learning approaches. The pedagogy and the mode of delivery, I combine them together. Okay, the teaching approaches is your pedagogy, your learning mode of delivery. So we use self-directed learning, we use project-based learning, we use interdisciplinary learning. Kickstarter culture is like your maker's culture. Experiential learning, so they go through the whole process. And then flip teaching. Okay, so that means a lot of homework they have to do at home. Then they come to class to do exercises. So these are the way. This is the teaching and learning delivery and the pedagogy that we use for this particular engineering design modules. Okay, the assessment. Now this assessment is a bit tricky. Okay, the assessment, there are various types. You have group activities, you have 5-minute speeches, you have individual reports, you have peer feedback. That means students give feedback on themselves. And then you have demo, you have blog, which I've mentioned yesterday. Demo your products, then blog to ask them for reflection and so on. Okay, now for these particular projects, just now we talked about planning. Now, how do you give it to the students? Every student, there are many project statements. Every student is given one. Okay, so this particular project statement explain what the project is all about. And then I circle here. This is the statement that you want the student to do. Okay, can we design a vehicle? Like for example, this one. This is a floating what? Thermometer, is it? Okay, so the projects, you give them a brief history. Then you tell them what they need to do. Can we design a vehicle that can be remotely interacted to go to a certain location? Okay, so you give them a brief and you say, okay, this is what you want to do. Now go and do it. And it's again a multidisciplinary project. Okay, any questions? Okay, so you see, multidisciplinary project is done in so many ways. Not only one way of doing. But this is also after many years, we've done it. Every year we are trying to improve, trying to make it better. So this is actually after many years of hard work. Okay, multidisciplinary project 4. This is a very different way. This particular way is done through a program. Just how we talk about courses or module or subjects. But this particular one is different. It's done through a program. So there's a program called Diploma in Engineering System. It's a multidisciplinary-based program. Okay, so this program was very young. It's very young. I think it's only about maybe 2 or 3 years old. 2 or 3 years old. Okay, so when we design this particular program, we want the aim, with an end in mind, we want to make it multidisciplinary. And this program, there's one module which is called the Engineering Innovation Studio. I don't know why the module is called Engineering Innovation Studio, but it's called Engineering Innovation Studio. That's the name of the subjects. So how did they do it? Okay, the whole idea is to apply fundamentals of design and fabrication to create a reliable product that is part of a larger system. So we are talking about system thinking and then how interaction and so on. And the thing that the student needs to know is ideation and concept generation, which is your conceive and design, mechanical, electrical, electronics, integration of subsystem into a larger system. So now we are emphasizing more on the system thinking part. Okay, students do part system, how to put it into a whole system. Okay, this is the design process. Look at this, multidisciplinary. Now this one involved, again, like earlier on I showed you, involve lecturers from 3 schools, School of Design, Electrical and Mechanical. Okay, so combine to teach them the skill and knowledge and eventually the projects. But this is a diploma itself, it's a program itself. Okay, so the emphasis again is different. Okay, so under the topics cover, what are the topics that you need to cover? Every time when you plan, very important, what topics you need to cover. But before you do that, you must have the objective, the aim in mind, so that you know what topics you need to cover, so that your students are ready to do the projects. Okay, again, the lesson schedule. You have the projects, the phases, and then the schedule. You got to map them. Okay, and then some of the examples. Like example for this case, we wanted the students to do some exercise to help them realize. Okay, so we give them a very simple exercise like gear ratio. Design gear ratio to lift a 1.5 kg weight using less than 70 gram force. So these are some of the, of course there are many exercises to prepare the students, but this is one of them. Okay, another thing that we also ask the students to do, you see, whenever you ask them to do a project, you see that the car racing is very exciting. They all look forward to, because why? They can relate to car racing. Who can't relate to car racing? F1 formula, everybody knows. Okay, so when they see car racing, oh yeah, it's F1 formula. So another way is you inject games. Games. So we have one of the projects where they have to design, conceive and design ideas for games. So I'll show you some of these electronic mechanical games. See how complex they are. So this is one of the projects. So you can show them videos, to give an idea.
Hi, my name is Roland and welcome to my Vectrix Roller Show. Again, I would like to show you something special. We will have a look at 3 mechanical tabletop games from the 1970s and 80s, and I showed you already some electronic games from that era on my channel. For example, I showed the excellent game Firefox F7, which was one of the best electronic space shooter games you could get back then. I will link to that video just in case you have not seen that already. Some people think that arcade games started with the invention of electronics and integrated circuits. It must have been a simple explosion effect which slows down or even stops only cars on the left lane, and I can only guess that the game is not broken and that's how the game was intended to be. I could not find any video now showing that exact game in action to compare it, but looking at the game
Okay, let's look at the mechanical part.
Motion light beneath in case of a crash. This
You see?
game is a nice and interesting collector's item. Gameplay
It's a very
wise,
good way of showing them how
let's think about it.
mechanism works.
Racing video games are basically simulation games, and usually old racing games in general didn't age well. And here we have now an electromechanical game simulating an old electronic video game, so that definitely does not help to get great gameplay that kids would enjoy much today, I guess. Even I didn't own such games back then, I still remember that my colleagues.
Okay, so you show them. You show them these are things that happens in the past, but this is a very good way of illustrating mechanism. How else can you illustrate? The gear system and so on. You show them how to use, how to program and so on. Then based on this, you then give them these projects. Okay, you say, okay, I want you to design electrical mechanical games. Okay, so this is produced by the students. So they design something like that. They get ideas, they do research, find what is needed. Then after they have come up with the concept, you can ask them to build a prototype. Okay, so this is also another way. If you can't afford to buy, say, very heavy machinery, this is another way of looking at things. So be more ingenious, be more, creative. Think of ways to teach the students, make them excited. Okay, active learning. Okay, make them excited. Get them to want to do the course. Okay, so it's another one, the design. This is like the ping pong ball, right? This is done by the students, by the way. Okay, so this is another way. Now, I have one more section, so I'm going to skip 5 and 6 and go straight to, okay, this one for you to refer to on your own. Okay, I'm going to go straight to these projects, which is a multidisciplinary projects. Again, this is done very differently. This one we have a final year projects, and then we got students from the various schools to do the final year projects. So I just show you these projects. Okay, this is another way of introducing multidisciplinary projects. This is done by the students.
We are in charge of the development of aircraft instrumental and the electronic instrumental system.
Is
So
it
we
impressive?
did on the wiring of the instrumental panels as well as the knobs, and from there we process our signals into the DAQ systems and we
You see,
program
we
it
prepare
into
the students so that eventually they are able to do something like that.
Hi, this is Ziyong. My team and I designed and developed the control loading system for our motion platform simulator system.
My team is involved in the development.
The student is from the
design and
aeronautical-
application of the full
yeah, these are
motion
aeronautical
simulator
students.
structured with the interchangeability concept. Interchangeability concept means that we are able to change the different types of platform as and when we want.
My team and I are in charge of graphics development.
Okay, this student is from the electrical department.
We reverse the effects of distortion and project two images onto a curved screen such that they appear as one.
These are the lecturers involved. Okay? Okay, so that projects, okay, the first phase, okay, I have to be honest, The first phase is actually done by students and lecturers, okay, from the various schools, the software, the IT schools and so on. And the initial model, the flight simulator, cost about nearly $500,000. Okay. Subsequently, what happened? We give it to the student to do. So what the student did was, the whole modules can be taken out. So initially it was designed for flight as a flight simulator, but later on they changed it to a car simulator. Okay. So you saw the student building, so they can take the whole carriage out and then replace the carriage with a different carriage. So the carriage can be taken out. Okay. So this is actually one of the very first multidisciplinary project that we do. This is the very first one. What I have shown you from 1 to 4 are newer. Okay, so we progress, from very simple getting student involved to making it part of the curriculum. So you see the progression, okay? You make it from very simple. So if you want to start with a very simple one, then because when you put it as part of a curriculum, it becomes more plan. You need more planning, like what I've shown you. Huh? Okay, the last one, 6. This is our iconic projects. It's also a multidisciplinary projects. But the students built this and they actually raised against the world. Okay, so we started off, I think, this is the fourth time. So we participate, I think, from the second one onwards. Second, third. So I just want to show you some of the pictures. This is the one that they have developed, Spec 3. This is in 2014. And in 2016, there's another race, which is this one. This is the latest that they have participated. But what happened was the students spent many weeks developing this. If you read in the news, this car, okay, was supposed to ship out to Australia for a race in Darwin. But unfortunately, it caught fire and the whole car was burnt. They spent weeks and months building a very nice very nice modern car, but it was burnt. Okay, but eventually one of the board members, wanted to donate, wanted to help the students, and agreed to pay for transporting the car by aeroplane. So it became very expensive. So he agreed. So the student took, I can't remember, 2 weeks or 2 months to put the car together again. Unfortunately, did not win because the car was put together very quickly. But they managed to do it. Okay, so they raced for 3,000 miles from Darwin all the way to Adelaide. I think, I'm not sure about the roads, but it took them. They managed to compete in the competition. So this is also one of the projects, the multidisciplinary projects. Okay, now last 10 minutes, we talk about multidisciplinary projects. So now talk about cross-functional. In the multidisciplinary projects, you also have cross-functional activities, correct? So I'm going to show you a cross-functional real-world projects. Okay, this teaching factory was developed by my team and I, okay, more than 10 years ago. So at that time, there was call from industry to say, okay, your students, when they come to us, I still need to teach them. I still need to spend half a year or 1 year to teach them before they can help me produce products. So what we do is we develop this teaching factory. That means we bring real-world projects for students to work on. So for the final year students, they actually work on real-world projects. And these particular projects, okay, the focus, what's the focus? I want to connect the school, the know, the workplace, the doing. So the aim is, we start with an aim in mind, what I want to do, or what I want to get out from these projects, based on the feedback from industry. And then I want to equip students with the proper competency. Remember, this is the teaching for projects for machine development. So the competency is different. Okay, the skill set that I need to teach them again is different. So very important, you must always ask yourself, what competency that you want to teach the students? In order to achieve that, what skill set must you infuse into the curriculum? And then the workplace know-how in the context of relevant problems. How do you solve problems when meet with problems? And then finally, the process of solving authentic problem within a real business environment. So these are real. We're talking in terms of hundreds of thousands of dollars of projects that is going to be handled by students. So the industry are aware But of course, I have lecturer as backup. Lecturers are the main designer. The student will help out. But the industry are aware that the projects that we are going to develop for them, the machine that we're going to build for them, the students are going to work on it. So you got to tell them beforehand. So they accept it. Okay, good. So that means to say what? You got to bear some percentage of losses, because if it's going to be done by students, there's going to be a lot of error. Okay? So these are all built into the projects. So that means you got to be upfront with your whoever who's going to ask you do the projects. Upfront with them, it's going to be done by students. So they are willing to bear that small percentage of loss. Of course, we try to eliminate, but no way. Okay? Every project, there's bound to be some losses, because it's going to be done by students. So these are the things you got to tell your industries. Okay? Then you engage students in investigation and solving authentic problems, and can encourage and offer students a good opportunity to develop the ability. See? Important. So the students, most of these students, I started off with 40 students. It's a very expensive program, but the 40 students, before they even graduate, the company already, most of them will have jobs and very high pay, because the company knows their ability. And I have a feedback from the company. One of the bosses, he was very pleased. He said, "Do you know you saved me 1 year of my time? Your student come to me prepared. I don't have to spend 1 year training them." You see? So that's the beautiful part, because the student get to learn, the staff also get the opportunity to do outside projects. Okay, now how do we make this? Since it's going to be a company project, so we actually model. Okay, this is the knowledge transfer. I put it there. Okay, this is our full-time students. The special thing about this project is, although we train full-time students, at the same time, companies send their workers, their employees to learn as well this particular model. So we call this continuing education. So in the night, we use the same methods that we teach the students. We also teach the employees, people who want to upgrade themselves. Okay? And we emphasize on design, fabrication, assembly operates. Conceive, design, implement, operates. But we are very particular. You cannot tackle all industry. So we are very selective. We choose 2 types of industry: the precision engineering and the medical products. There are many industries out there, but there's no way we can do it. Okay, so you got to be very selective. What you want to do? Okay, the end in mind. If you try to tackle all industry, then I think you're stretching yourself too thin. So if you are focused on certain industries, okay, this is similar for non-engineering as well. Okay, you focus on certain industry, because most of the technology will be the same. So it's okay, because your technology can be repeated. Okay, so these are the 2 industries. And then for the project scope, it is a cross-functional. Cross-functional, that means what are the functions I want the student to learn? Remember, it is multidisciplinary, but on top of that, I'm now training them to be able to take up different functions. Okay, so what happened in the first 2 weeks? The students are given the opportunity to go through all the functions. The sales, we actually model after the factory. That's why it's called teaching factory. Okay, in the factory or in a machine development company, these are all the functions that they will have to perform: sales, design, logistics, assembly, electrical, programming, commissioning. All these are different sectors. So the students are exposed to all these functions in the first 2 weeks. Then they're given a chance to choose which one attract them, which one they would like to concentrate on. You cannot have all the students doing commissioning or all the students doing sales. Then you fail. Okay, you fail in your curriculum. So the student then choose. Now, notice here, I call this the teaching factory 5+1 model. Why do we call it 5+1 model? This is, at that time, was have great difficulties in getting this approved, but it was approved. 5+1 because in any program, there are 6 semesters. Okay, so we try to squeeze all the modules. We try to squeeze in such a way that they can finish all their subjects, the theory subjects, in 5 semesters. Of course, in the process of doing this, we have to merge certain modules, we have to reduce some hours. without compromising the content. So we change our mode of delivery. So a lot of things have been practiced when you do this. Then after that, they are free for one whole semester to do projects and no attending classes. Okay, why do you think we go to this model? Anybody? 5+1. Why do we have the free one semester? So the students, there are 40 students, 20 will do semester 1, 20 will do semester 2. What's the reason for doing this? Anybody? Now, industry projects, can you tell the industry, sorry, deadline over. So if your deadline for closing a project is in March, they come and see you in April. You say, sorry, you've got to wait 1 year. So what happened? Can they wait 1 year? They cannot wait for you for 1 year, right? These are industrial projects. They want it to be done in 3 months. So you tell them, if you ask them to come back the following year, they will go somewhere else. Okay? So that's the reason why we introduce this one whole semester. That means to say sometimes the student do more than one project in one semester, depending on how many projects we bring in. So what the student do is, so one whole semester. So anytime the industry comes to us, to ask us to build machines, we are always ready to receive them. Okay? Because at any one time, there will always be 20 students to do these projects. So that's the reason why we introduced 5+1. But of course, the model has now been adopted by SP, and now they send students out for internship and so on. But initially, when this was developed with this in mind. Okay? To answer to industry request anytime. That was what was initially planned. But now I think SP has bring forward 5+1, but allowing students to go to company for, say, one whole semester. But originally, when this was planned, it wasn't meant for that purpose, but meant to answer to industry request, so that we don't have to say, come back next year. You miss by 2 weeks, you say, come back next year, because the project registration is closed. Okay, for the normal program, this is the case. So every time, come to January, we'll get industrial projects. And then by April, when students have selected the projects, we close registration. Then they have to wait for another year. In this particular case, they don't have to. Okay, they can come to us anytime. Okay, so now this is talking about planning the curriculum. How about the workspace? We talk about workspace. Now, this workspace, I did not do any design thinking, but what we did was we modeled after the factory, how a factory would allocate or design the workspace. So if you look at this workspace here, this is how industry would do. Okay, you have the design office, reception area. We have a reception area to receive guests because this is a industrial project. And then we have meeting rooms, we have logistics office, we have the storeroom. Okay, and then we have a machine workshop to support the fabrication of the parts. Okay, then we have a software development. Some of the machine need software, like example, the human interface, human-machine interface. We need our vision system. If the machine needs vision system, so we need software. So we also have a room to support that. And then we have the flexible assembly system. So once you have developed your projects, you conceive and design your projects in the design office. You build them, but of course, most of the parts are sent to outside contractor for building because they are more professional. But we always insist the students must at least fabricate a few parts. So one of the conditions, they must fabricate because they have to know how things are done. Otherwise, they cannot tell the contractor how to do it. Okay, once you've done the design, you ask the contractor to do it. The student cannot appreciate. So one of the requirements that they must know, okay? And then, of course, they have assembly. So if you come at different time of the year, you see a lot of ready machines all waiting to be shipped out. Okay. So this is modeled exactly after the factory. And then if you look at the design office, this is how it looks like. Okay? It's like when you walk into any company, this is how it looks like. The designer working in computers and... So this is modeled exactly after that. Okay, so we provide PC, we provide software and so on to support. So the software we use, we also based on industry. At that time, they use a lot of what software was called it? SolidWorks. Are you familiar with SolidWorks? So at that time, most company want SolidWorks. So we were actually teaching students Pro E, but because of company requirement, so we have to teach students SolidWorks because they do not have Pro E, they only have SolidWorks. So we actually follow industry standards and needs. Okay, and this is another place where this is the assembly area where the students notice the fanciful cubicle here. Okay, each cubicle. Now this is for another program, very similar to Teaching Factory, but these are for the innovation students. So each students, again, is 5+1. But each students, again, multidisciplinary. But each students are given a cubicle, like their own company. So they design their logo and so on, and they're given the space for 4 to 6 months to work on the projects. Okay, it becomes their working space. And then when they come to exhibition, all this can be removed and make it into a big space for exhibition. Okay, so Teaching Factory, we have what you've seen, and then here we have another kind of Teaching Factory 5+1, but the focus is not on machine development. The focus is more on creativity design, but the model is the same, the framework is the same. Okay, this is the supporting equipment to help them to do to help them perform fabrication or fabricate the parts. Okay, now for this particular 5+1, again I mentioned earlier, we run like a factory. So we have a manager, we have research scientists, we have lecturers. There are many lecturers involved because multidisciplinary. And then we also have supporting staff. Notice the supporting staff here. Okay, because it's run like a factory, so we have supporting staff to support the students. Because students, sometimes the projects, if it's urgent, they work overnight, no? They can stay on campus for a few days just to get the project out, like what you would do in a real factory environment. Okay? Okay. I'll show you some of the projects that have been developed by us. Okay, jingle for time now. What how long? Then after that, now the exercise I cut short down, one section go down. Okay, these are some of the machines built by this particular group of students. But of course, with the help of lecturers. Okay. Yeah, I thought there are. These are another one thing to motor. Okay. Okay, finish. Any questions? This exercise will be done after tea break. Any question you want to ask? So here I'm trying to show you the different way you can do multidisciplinary projects and also how you instill cross-functional. Now the students, I mentioned earlier, different function. Those who are in charge of commissioning also have to write a manual. So we actually produce manual for the company. And then they have to go to the company to teach the people how to run the machine. Okay? So that's why the experience that they gain is very extensive. Okay, real experience. Okay, any questions? If not, we stop for a break. Then we come back, we do a simple exercise on how you design multidisciplinary projects. Any questions? Now remember, these multidisciplinary projects, what I've shown is engineering. For the non-engineering, you can also use your own examples. Okay, so that's why I wanted this exercise, just to tickle your mind a bit. Any questions? All look so serious now.
How many institutes in Singapore that use this concept?
Okay, now there's one other institute which is called Nanyang Polytechnic. Okay, because they started off as a German Link Institute, so they also do, but there's one different. Okay, I've seen how they do, but they also work on industrial projects. I'm not sure whether what I say now is correct, but at the time, the design was given by a company they actually helped to build. So when I saw it, I wanted to do something different. So I said, why don't we design make machine development? So now the center is not called Teaching Factory anymore. It's called Machine Development Center. So we then changed emphasis. We say, why don't we also do conceiving and designing? But the other polytechnic, most of them are also doing this now. Now I think it's quite common. But more than 10 years ago, it wasn't common. So I must admit, we were not the first. Okay, Nanyang Polytechnic was the first. But I tweaked the model a bit. They changed the model to suit us. Okay, any other questions? But so far I've shared this with a few. I mean, this is the first time I'm sharing this in details because it's advancing CDIO. But most of in the university we have gone to, some of them have industrial projects, but many have difficulties getting industry to give them projects. Many has difficulties. Any other questions? Okay, if no, we want a break? Okay, everybody looks so serious. Is it boring or what? Oh, very sleepy or serious. Okay, break time. 15 minutes.
You did the first step, right? So you have completed the first step is to identify and clarify once again what are your key teaching and learning methods and what are the learning outcomes, right? So that's the first step. The second step you need to do is then to select from the list, alright? Select from the list 3 most important ideas from that list that has a major impact on space. Clear? Alright, ask yourself, from the list of teaching methods and the list of learning outcomes, maybe you have a list of 6 or 7 different things. Ask yourself, what are the 3 or 4 ideas from that list are most important in changing or impacting the space? Okay, about space. Okay, I'd like you to highlight very quickly. Maybe you draw a circle around it. Have a quick discussion now. Okay, collaborative, social, interactive, and that group they have high boxing. No, that's okay. They have things like being comfortable, being playful. Okay. The next thing we want to do is those words are spatial quality words or characteristics. We want to translate them visually. Now, if you're going to talk to an architect, I say, I want the space to look playful. How do you do that? How do you visually explain that? Don't worry. What we're going to do for you is this chart. We're going to share with you some pictures. Okay? So what we intend to do, we're going to give you a collection of pictures of different spaces. And now you use a post-it. If you have your post-it say collaborative, which pictures do you think is collaborative to you? Now you put the word collaborative next to the picture. So when you talk to the architect, we want a collaborative space to look something like this. Immediately, it helps you to be able to translate spatial quality into visual language. Understand that? Can we do that? Alright, so you have a list of characteristics. We're going to give you a set of pictures, and now for you to match the qualities, spatial quality into visual language. Alright, so my colleagues here will be giving out to you. When we actually do a learning experience design or space design, okay? Now, after you have completed this exercise, what do? That's where we co-create with the architect. That's where we start to communicate what the space may look like using visual languages. Okay? Alright, so for this exercise, we'll stop here. Okay, so now you have a sense of how we go about, creating those interesting learning spaces at the Polytechnic. Now, so the next thing we would like to do now is maybe some of you would like to share your experience. Anybody like to share how do you feel about this whole experience? What have you learned from this experience doing this exercise? Anybody? Yeah, I'll bring you the mic. Anyone would like to share? I hope you have fun at least. Okay? Yes, alright, okay. The young man here, he looks like a designer. He looks like a designer. The real one is the real designer. Okay, cool. First.
This activity is very fun. Yeah, very funny.
Okay, alright.
From the art side, they very like it because they can understand someone who don't understand art. And the guys who don't have art very like this way because it can explain more easy to understand each other. At least how to describe something, for example, like the word collaborative. How to explain collaborative to the architecture they describe that. This way is very nice.
Okay, thank you. So remember we started by talking that in space design we do two things. We try to incorporate pedagogy with architecture. And that's what we have just done. Congratulations, you did it. Well done. Alright? Very, very good. Therefore, because you did it, you deserve a break. Of course. And please go for your break and please come back before 3 p.m. Alright? We're going to start with the next session. Yes? Sure. Oh, this gentleman has asked some questions. Sorry, don't blame me, huh?
This process we are going to design for the learning space, for our students, right?
Yes.
So this process should be done by us, or teacher, or should be done by students?
The answer is yeah. Actually, 4 groups of people. Remember I shared with you the teachers, the students, designer, and the architect. Eventually, we put them all together under one roof and we lock the door. No one's allowed to leave until they come up with a solution. Now, alright, please go for your break and please come back before 3 p.m. Thank you.
Okay, I know it's very challenging time, yeah? Tomorrow is a weekend is coming up. The program is coming to an end. Okay, and we have a topic on quality assurance. So do you have similar quality assurance system in place? Yes? Okay. So sometimes are you asked to submit documents or interview for audit? Yes? Okay. So you have some experience in quality assurance? Okay? Right. That makes my job very difficult now because normally nobody likes quality assurance. Okay, but let's have a different perspective of this, all right? Let's look at how, since we are talking about advancing CDIO, all right, and how it fits into our existing quality assurance system, all right? Okay, so let's get going, all right? So basically we have reached the last part 4, okay? So being a very nice person here, I'll give you a test question, a quiz question now. What is part 4 all about? We covered part 1, 2, and 3 already. What is part 4? What is part 4? I hinted to you that I'm a very nice person. So what is part 4? Yes, sustaining. There. Sustaining. Alright? See, the answer is there. Alright? So we will just briefly share with you what will be covered, alright, in the full scale workshop. Alright, so that you have an idea. Okay? Alright, so what are we emphasizing? The key word is sustaining. So how do we keep going after the initial implementation, after you start to have some new ideas now to advance CDIO? How do you share this with other people who have not yet adopted CDIO? How do you yourself, gets better at doing CDIO, implementing CDIO? All right. So, okay. But before we start, let's just have a good understanding what it means by quality assurance and quality control. All right. We are probably more familiar with quality control. All right, because whatever things that we buy, we expect it of a good quality, that it will not break down. Okay, so quality control, all right, looks at the product that has been made, right, so that it meets a certain performance requirement. Okay, so it is aimed at finding defect. If a product is produced and when it's checked that it's find that it has some defect, it will not be allowed to go to reach the consumers. So it's a defect detection. So that's a bit too late in a way because the thing has been made, it's not working. All right. So a better way is quality assurance. We want to make sure that the process that goes into making a product is reliable, is robust, and the product is of good quality. Right. So the focus, all right, is on the process. That's why you keep hearing Linda Chonghua keeps talking about the process. All right. So it is defect prevention. All right. Defect prevention. So every institution, and including education institution, all right, we have a management system that incorporates quality control and quality assurance. Okay. So the other 2 or 3 words here that is we use quite often: assessment, evaluation. Okay, so here they are more or less, we take them to be more or less the same, right? It's the activity of checking the processes, the teaching and learning processes, all right, and the results in the institution. Another important one is accreditation. Now, I understand that some of your program does go through national accreditation. All right? Is that true? Okay, yeah? That's some or all. Some. All. All right. Okay? So, now, a little bit of history of CDIO at the beginning is that, okay, as Chonghua shared on Monday, or Linda shared on Monday, all right? It came about because the industry are not very happy with the graduates produced by the university. All right? So, as a result of that, the American, all right, the Accreditation Board for Engineering and Technology, ABET, came out with a set of requirements specifying what a degree program, all right, must cover and what type of graduates must they produce based on the requirement for the industry specified in terms of learning outcomes. So CDIO is a response to that challenge. So that's why they come up with a set of syllabus and standards to guide the universities in redesigning their degree program. All right, so that is basically how it came about. And to make it to ensure that the university comply, all right, the program has to be accredited by ABET. So many universities, they adopt CDIO because they need to have ABET accreditation. Otherwise, they can't, their degree is not recognized. All right. So that is one of the purpose. All right. So mainly for accreditation. All right, but if we take a broader look at it, okay, if the purpose of in the education sector is to educate the young, to prepare them for the needs of the country, all right, educate them for life, for work ready, life ready, and world ready. All right, we look at education, quality of education in a much broader context. It's not just for accreditation's sake. Okay, so this model, this framework shows that what it means by having a good quality education. All right, you must have a good program design. How do you design your program to be responsive to the needs of the industry, to the changing circumstances when you identify using STEEP? All right, so of course you can have your program accredited. That shows that it has up to meet the requirement, right, of the industry, of the accreditation body like ABET. But more importantly, you must have a quality assurance system to continually improve your program. Okay? Because why are we doing STEEP analysis? Because circumstances change, right? Demographic change, environment change, economic factor change, political factors change. Right? So we must have a way to recognize the change and make corresponding improvement, adjustment and improvement. So quality assurance. So these are the components of a quality program, all right, quality education that we provide. So in the in Singapore, all right, in the polytechnics context, we are governed by the Ministry of Education. Right? They spell out a certain outcome, right, like ABET did for the degree programs. So internally, we have our own system, right? It's known as the Academic Quality Management Framework. It's based on ISO 9000. So it guides our operation, right, our processes in running managing our diploma programs, all right? And with the adoption of CDIO, right, we also have a sort of an international benchmark because collaborators in the CDIO consortium comes from all around the world. So every year we can meet up in the international conference, we do self-evaluation, right, and compare, we know what other people are doing. So it's a form of a benchmarking for us. So in that way, we have a robust, a complete quality assurance system. Okay, oops. All right, so very, very briefly, all right, the Polytechnic Quality Assurance Framework. We have 5 polytechnics in Singapore. So the Ministry of Education come up with a set of framework to make sure that all the polytechnics, they meet a certain standards in terms of the education. Right? So I won't go into too much of the detail of this, all right? But just like any quality assurance system for education, right, we will be looking at all aspects from the governance and the leadership, how the management, all right, runs the polytechnic, the institution, what is their philosophy, all right, how they manage it, what type of strategic planning that they have in place to scan the environment, do your STEEP analysis, right, and most important of all, of course, the teaching and learning. All right, and we also look at industry linkages. It's very important because a quality program is one that is always relevant to the industry. So the industry linkages is one factor that, all right, the assurance system looks at, and not forgetting, all right, all the library, all right, estate development management, all right, if your leave breakdown, all the services, examination system, admission system, all right, all the services. So let's not neglect them. Okay, so very briefly about the AQMS, right? As I said, it's based on the ISO 9000 system, so it's probably something very similar with what you have, all right? So, of course, first and foremost, evaluate and improve the course quality. And second one, you look at the second one, okay? The best possible student experience with the resources available. Because we recognize today's students are very different. They cannot sit there listen to you talk for 2 hours. Okay, not even 20 minutes, let alone 2 hours. All right. So what type of learning experience that you want them to have? All right. So if there must be a way to detect any defect, right? Like for example, many students fail the exam for this particular year or this particular subject. All right. What is the root cause for that, for example? All right. And also very important to identify good practices. All right. I hope this platform like this today, all right, for these 2 days, is a chance for you from different faculty, from different faculties or different campuses to come together, and hopefully you get to share some of the things that you do maybe differently or better compared to one another, right? And that's best practices that you can take away, all right? And of course, every now and then we must prepare ourselves for external review, right? Because if you only have an internal system, yes, you say it's good. How do everybody else know that it's good? Because you say so. All right? Of course, I'll say my system is good. All right? So we must have some sort of external review. That's why we have all this audit. All right? So our framework is very simple. All right? There is a design and development phase, implementation, and review. Right? It follows the ISO 9000 plan, do, check, act. All right? So what is showing here is that the typical the stage that you go through from the analyze the need for a new program, go ahead and design the curriculum, okay, go ahead and carry out your delivery. So you teach them in a 3-year program, 3-year duration or 4-year duration, and every time you have a assessment to see what they learned, and you evaluate. So that's a very typical cycle. Yeah. So what is shown below here is equally important, is a staff development plan, because the most important asset in the education institutions are the people who deliver the teaching. All right. So people like you and me. Yes. Shall we give ourselves a round of applause here? Yeah? No? Okay. Right. So, who are involved in AQMS? The short answer is everybody. Alright? Quality is everybody's business, not just the dean's business. Alright? Not just the board of director or board of governors business. It's everybody's business. All right, all the way from the board of studies, all right, the management team, down to the individual lecturer who teaches the module. So everybody is involved, of course, at a different level of responsibility. All right. Okay, so this just shows you a slightly more detail of the AQMS, the different steps involved. But interestingly, when I first look at this AQMS is in existence way before we have CDIO. Right? It's already there. Right? It's an existing quality assurance system. But when I first exposed to CDIO, right, when I look at this, I see that there is a lot of similarity. How do you come up with a new course or a new program? You conceive it. Right? Then you design it. All right, a new program. What course, what subject should you teach? How should you deliver it? Right? You come up with a timetable. You implement and you teach it. You operate. It's exactly the same. All right? So that is the beauty of it. All right? So CDIO is also based on the ISO 9000 system, actually. All right? So, okay, this is another one. The detail, I'll just skip that. All right, so a bit more in the evaluation. So we have many ways to evaluate. So this sample shows you the teaching observation feedback for faculty, for lecturer. So what happens here is that one day while you are teaching, talking to your students, you find that your boss is sitting at the back of the classroom. Do you have that here? Do you have this mechanism here? Yes? Okay, so you know what it means. Alright, your boss is looking at how well you teach. Alright, so he will give feedback if he finds any area that you want to improve. Alright, okay, another sample is the annual course review. So every year, okay, when I say the course review here, alright, it's a program, yeah? We use the word course. So every course, every program has a chairperson. So the chairperson will have to do a review, write a report every year. Okay, so the input, the report comes from many sources. One of them is the teaching observation I shared earlier. But every subject, the teacher also must do a review, must submit a report. So the course chairperson look at the overall submissions, look at the examination results, and look at the analysis of the results, submit a report. So this has to be done every year by the course chair. So this is one. These are some example of the mechanism. So in this introductory course, I'm not going to go through all of them and how they work, right? But just to summarize again what we say, because this is one of the most important document. It is for the entire program, right? So you take input from the individual lecturer level, all right? So at the module level and out down to the program level, and every program in the Polytechnic has to do this, right? So and it goes up to the deputy director who look after the courses, all right? It will endorse by the director. It will go to the, all right, higher management. So that is how we keep monitoring the quality. Okay, so there are many performance areas in the course review. So we try to mirror the requirement at the requirement at the Ministry of Education level, right? So these are some of the performance area. It should be quite familiar to all of you, so I will not go into too much details, all right? Okay, so these are the other areas. So do take a look at it, right, in your own time. Okay, so review. All right. So what are we reviewing? All right. This is done mandatory every 5 years. So we already have annual review every year. A major review exercise will come in every 5 years. So this is to make sure that your course is really relevant and it's not just reviewed by your course chairperson. Because again, if I review my own program, yeah, of course it's good. All right, if I say no good, I'm out of job. All right, okay. So after 5 years, okay, we believe you for 5 years. Okay, now after 5 years, let's see whether you're telling the truth or not. All right, so 5-year course review is done with the external panel. So for this exercise, it's very massive because you have to gather a lot of information, examination results, answer scripts, and assignment questions, right? You have to compile them, prepare them, because an external party, they can sample it, right? They can sample it. So there are the stages, all right? So they will come in. The first visit is to discuss, to understand a little bit more, and then take their time to review, give their recommendation. And the second time, the second meeting, right? They will again discuss. Right, what are they finding? What are their findings? Then they may give recommendations. All right. So that is basically the 5-year review process. All right. So okay, what happened after that? All right. 3 possible scenarios. 1, the panel recommend that the cost be removed. It's real, it happened before. In the last 5 years, I think we shut down 2 programs. All right? Because it's deemed no longer relevant. The feedback from the industry says, no, we don't need this anymore. The industry is no longer relevant. So the program is shut down. So it does happen. No longer relevant. All right? So of course, most of the time, it's still ongoing because it's still needed by the industry. Okay? So there will be a scenario C, all right? Continuation of approval with additional recommendation to further improve. So this was a well-managed cost program. This might be a very likely outcome. There is somewhere in between, all right? Not removal, you can continue, but with mandatory conditions. That means you can continue, but or provided that you implement these changes. Right? So there are conditions required for you to change, mandatory, compulsory. You must make the modification. So it might happen in that way as well. Right? So that is cost review. Any questions so far? Does that sound familiar? Yes? All right. Okay. So every 5 years we have this polytechnic-wide review as well. So they have, in this case, the panel is called the External Review Panel commissioned by the Ministry of Education. So we have no say who the panel members are. Right? We pray that there are somebody who knows us and is a good friend of ours. But, well, okay, they have a panel to review. All right, so the last time that we have a review was back in 2013. So another one may be coming up in a very near future. Okay, so all right. So that's very briefly about the quality assurance system which all education institutions likely to have. Now, if you were to adopt CDIO, you're implementing CDIO, the first concern that I have from the staff, oh no, another system. All right, we already have internal quality control. We already have external review. Now we are asked to implement CDIO. So will there be another audit, a check? Do we comply with CDIO standards? What do you think the answer will be? What do you think? Yes or no? Yes or no? What? Give it a shot. Nobody dare to say anything. Okay. I'll give you a clue. I'm a nice person. Answer is only 2 letters. It has 2 letters. N-O. No. All right? Don't worry. So, what we have done is that instead, what we are doing, we look at the CDIO requirements, because I say that it's also based on ISO 9000. Our quality assurance system is based on ISO 9000. So there is a lot of similarities, right? So what we are doing is also called, all right, I'll skip this one first, a mapping exercise. In other words, we see the requirements of CDIO standards. How does that correspond to our quality system? So you can see that, all right, on these slides, all right, standards 1, 2, 3, 4, 5, 6, 7, 8, 11, 12 matches very closely with the AQMS. Okay, it matches very closely. Now the the two other standards, which is standard 9 and 10, right, that pertains to faculty development. So that is addressed in the Polytechnic, right, by a different standard. It's called the People Developer Standard. This is the government's requirement for all the management of human resources, good practices in management of human resources. So, looking at it collectively, all right, our AQMS and our People Developer Standards together, they can be mapped. They have a correspondence with the CDIO, the 12 CDIO standards. All right. So the selling point for CDIO now is made easier. We just have to explain to our colleagues that CDIO standards provide us, with a systematic methodology how to carry out our course management. All right? How do you make sure that your learning is relevant? Okay, I'm going to adopt active learning strategy in my classroom. So there is a method, there is a way. All right? How do you make sure that the student understand the real world working environment? Oh, we are going to have multidisciplinary project. All right? That is addressed in the CDIO design implement experience. So there are many things in the CDIO standards that addresses the needs for the industry to make the course relevant, right? So you don't have to really do anything different, all right? But now you have better guidelines, right? Better best practices from CDIO people who implemented CDIO, who share with you how they do it, all right? So that is the advantage of it, all right? Okay. One more point, right? With regard to accreditation, right? In my school, my director strongly encouraged the different programs to obtain international accreditation, right? So because it's a form of recognition of the quality as well, right? So this is a typical mapping table, a simple mapping table that shows how CDIO meets the requirement of ABET. So the letter here A, B, C, D, E, F, G, that refers to the ABET Engineering Criterion 2000. Alright, so that's the ABET requirement. So is this here, 1.1, 1.2, etc. These are the CDIO syllabus. So different part of the CDIO syllabus address different requirements of ABET. Okay, so that's why I said earlier, many people, they adopt the CDIO because they want to get ABET accreditation. All right. So likewise, this is Institution of Engineers Singapore. All right. They have a set of learning outcome. All right. It's very similar to ABET. So if you do a similar exercise to demonstrate that it meets the requirements. So now this table shows that CDIO can meet the requirements of Institution of Engineers Singapore. Alright, so different university or different country, they are using similar table. In Canada, you have another table like this that shows how CDIO meets the Canadian requirements. So in that way, alright, we see that over the years, the practitioners in CDIO, they share with us, CDIO can be used to meet many type of national requirements. All right. So this is just an example of my own program. I'm come from chemical engineering. All right. The program is accredited by the Institution of Chemical Engineers UK. It's a professional body of chemical engineers, and when I implement the CDIO and when they come to audit me, to do the accreditation, all right, they are looking for things like this. Okay, I'll read this text to you. Decision on whether a program is accredited and to what level. What level means whether it's diploma, bachelor, master, all right, will be taken solely on the basis of achievement of learning outcomes against defined standards. So the institution define a set of standards based on ABET. So we are evaluated based on achievement of learning outcomes. And this is very important. I underline this word. All right. Whatever that ABET or Institution of Chemical Engineers prescribe, that is the minimum. You must meet this minimum requirement. Okay, so they have a minimum requirement in the 6 focus areas: maths and science, core engineering, engineering practice, design and design practice, embedded learning. All right, they are talking about sustainability, safety, health and environment. Must be embedded. And embedded learning, general transferable skills, teamwork, communication, thinking, etc. So in each of the 6 categories, they are given us points. All right, each category we must meet a minimum number of points. We fail one category, we fail the entire accreditation. So ABET is very similar. All right, so we must do well in all 6 areas. We must meet the minimum of all 6. You fail one, you lose everything. All right. So again, they just reiterate the same point. They must have developed and demonstrate ability to integrate transferable skills. They are looking for the demonstration. They will interview the students. They will interview graduates. We must find the students for them to interview. We must see that they are able to demonstrate ability to integrate transferable skills. So if you are a graduate as a chemical engineer, right, you must be able to communicate and talk like a chemical engineer. So that is the requirement. All right. So just some example, some text of the what it means in the some of the focus areas and the simple mapping to CDIO. All right, it's a simple mapping to CDIO. Again, it's not very difficult to demonstrate this requirement, meeting this requirement, this mapping. All right. So in short, okay. So how we communicate to our fellow colleagues. All right. Now CDIO doesn't mean that there'll be more work for you in terms of quality assurance. All right. So this is the summary of the approach, all right, of our communication, change management on CDIO adoption. CDIO standards, it can be used to drive continual improvements. Since continual improvement is something that we have to do anyway, with or without CDIO. But CDIO makes it clearer for us. All right, what is it that we need to improve? Where is it we need to improve? How is it we're going to improve? All right. So the area of improvement, the skill gap. All right. Formulate an action plan, track progress. How we do this? All right. We can cover with you in the greater details. All right, in the workshop. And the syllabus itself is used to achieve the desired graduate attributes. So you say that your graduates must be a good team worker, must be a good communicator. All right. So you can refer to the CDIO syllabus. What does that mean? So basically, that is how, all right, CDIO fits into the entire continual improvement quality assurance system. All right. Okay. So most important of all right, is, again, I emphasize, is the people who do it. People like you and me. All right, we have great responsibility, capability. All right, capability. This is simple drawing here shows that, all right, there must be alignment between curriculum, what you want them to know, pedagogy, the way that they are going to learn, all right, and your own capability. So it points to the need for professional development. And very important, that there is this encouragement for every one of us to undertake reflective practice. Think about the way that we do it. We review the design of our learning tasks. Right? Is this appropriate? How can I do better? What is the best practice that I learned that I can incorporate? All right. So this, we build up our own capability here. All right. So officially, that's the end of the workshop. But I received a request to share a little bit more about mentoring. All right. So I will do that now. So you give me a few minutes. By the way, before that, do you have any questions? Okay. My talk is just talk, no activity. All right. So there will be a bit more talk, no activity. But there's always a but. There will be activity for you after that. All right. So just give me a moment. Hello. Okay. Right. Where am I now? This? Yes. Okay. So let me share a little bit with you my experience as a senior academic mentor. Previously, I am the deputy director courses. I look after programs. All right. So now I changed profile because I really like, after implementing CDIO, I really like to share this with more people. All right. So I now, all right, change the portfolio as a senior academic mentor. So I'll briefly share with you what is this scheme, all right? Because our role, what is our role? Okay, why do we have this scheme in the first place? Our role, etc. So, okay, first question: why is the need for academic mentor? Okay, why do we need master trainer like you? All right, to be trained to be more familiar with CDIO. Okay. It's not just for you to have coffee with your colleague later on, yeah, or go to spa together. All right. So why? Okay. Do you agree with this statement? Teaching is a complex process. Learning is even more complex. And the human being involved in the teaching and learning are the most complex of all. Okay, I like this one very much because that's exactly, I think, how I feel after teaching for 21 years. All right, that's how old I am. Before that, I still work in the industry. Okay, so why? So, one, importance and priority of innovative and effective teaching. We all know that the student demographic has changed. All right, teaching, that's why we are talking about, part 3 is about innovating, isn't it? All right, so innovating new methods of teaching and also equally important, effective. All right, we don't want students to have too good of a learning experience but learn nothing. They must enjoy learning and learn something. All right, offers career progression. This one is interesting from the Singapore Polytechnic perspective, because not everybody will become a manager, and in each school there is only one director of school. All right. So how do teaching faculty have a career progression? All right, by becoming a mentor. Third one, developmental and capability building. We realize that when we want to deliver good curriculum, innovative teaching, it's not just a matter of 1 or 2 person. All right, the whole teaching team must develop, all right, and deliver, because you can't have a student go to your class, very exciting, go to another class, drop dead boring. All right, so let's try to give them a consistent, pleasant learning experience. All right, so broadly, Now, you don't worry about these slides. If you want, I can give this to you. Right? I know it's not there because this is something extra I was preparing last night. Okay, so background. It's introduced in 2010 actually. So I started. All right, it's a 1-year certificate in professional development. All right, it's supported by our Department of Educational Development. This is the department that is responsible for faculty training. So the approach is face-to-face workshop and seminars, independent study tutorial. We actually have a flipped classroom. Right, we use a flipped classroom for this as well. And interestingly, you see this diploma-based project. So whoever who are interested to become a mentor, they are required to do a project in their school. Okay, for the duration, and the senior academic mentor like myself will help them with their project. All right, and they have to do a seminar presentation of their work. Okay, so objective, right? Strengthen the teaching pillars. Yeah, because in a polytechnic, there are 3 pathways, 3 career paths. 1, all right, of course, majority teaching. 2, those who are involved in R&D, who do more research work, they are on the technology track. 3, right, these are the teachers who become managers and deputy directors, director, right, management. To assist colleagues in implementing effective teaching and learning strategies. Okay? To allow academic staff to contribute according to their strength. To provide clear routes of career progression, as I mentioned earlier, all right, opportunity to reach the pinnacle of academic career. Because most people, they join the institution because they enjoy teaching. They like to teach. So give them more opportunities to do this, all right, and share with other people as well. So, all right, the roles and responsibilities. Okay, so there are a few major ones, such as curriculum design and delivery. This is a must, all right, because our faculty members, they are all hired from the industry. They have many years of working experience, but they have no idea how to design a curriculum. All right, coach, therefore, we serve as coach and mentor. I can't go too far away. All right, conduct educational research. Academic mentor needs to study, investigate, right, different research, education, carry out recent education research, which method works best, which method is better, enhance teaching quality, all right. Academic mentor can observe instead of teaching observation. Remember, I talked about teaching observation, all right. If somebody who's teaching observation not so good, needs improvement, all right, they can get the help from the academic mentor. All right, it's better than your boss sitting there and looking at you, isn't it? All right. So, and promote professional development. So, career pathway, you can start with the academic mentor, doing more mentoring and coaching, and you can proceed to become a senior academic mentor. AM is academic mentor. All right. So you will take on more responsibility. You lead the educational initiatives in your school, and next level you can go is a principal academic mentor, where you are actually carrying out things, initiative at the institutional level. So there is a new career pathway, all right, so that you can move upwards. Okay, so resources are available. This, don't worry, you can't read it. Is right. This is our intranet. So a lot of our professional development programs, they are all available in the intranet. Right? So there are some face-to-face, there are some blended learning, flipped classroom type of module that someone who is undergoing training as an academic mentor must go through. Right? So this is just a sample of what it is. All right. Okay. Now, very briefly, case study. I'm sure you are quite interested to know. Okay. what actually did I do? All right. So my program, just to let you know, right, is like Linda have said, right, ours is a 3-year diploma program in 6 semesters. So I have 120 students each year. The key feature of my program is product design, chemical product design, with a special emphasis on sustainable development, aimed at helping the community at what we call bottom of the pyramid, right? The poorest of the poor. So we have 5+1 curriculum. So we started CDIO, all right, in, like Linda said, 2006, where the 2 of us with 2 other colleagues went to Montreal. We roll out our course, CDIO type of curriculum in 2008. Right, I was very lucky to be declared the winner in the event organized by the Institution of Chemical Engineers Singapore, Innovation, Excellence and Innovation in Teaching, Education and Teaching. So CDIO helps me a lot. Okay, so all right. So remember I said that the 1-year certificate in higher education program, one of the components says diploma-based project. So each school have some liberty to design the learning experience for someone who is training to be a mentor. All right, that program is therefore designed by me. All right, because I have a colleague who wants to be a mentor. So how do I make her a mentor? So I design a program. All right, so I define what is the learning outcome of an academic mentor in my program. All right, so okay, to me it's very important that the person must be familiar with the literature, with the research, what works and what doesn't work. Okay, we are not starting from ground zero. There's a lot of research has been done. All right, let's find out what that is. It must be familiar, obviously, with CDIO framework. All right, will implement a change in the subject that he or she is teaching. Otherwise, why go and learn? All right, learn and without implementing is not good learning at all. All right. Will conduct an evaluation. Yes, you implement a change. How do you know that the change is effective? You must do an evaluation. All right? Because remember, continual improvement. All right? We must evaluate. We'll engage in reflective practice. All right? So this is something that I define my mentor. So we're doing all this is because alignment with the 2 standards, 9 and 10. All right? So the approach, you have seen this before. This is the philosophy behind. All right? This philosophy is actually based on what Lee Schumann called pedagogical content knowledge. Because we come in, we have a lot of content knowledge. All right? Now we can learn about the art and science of teaching, the pedagogy, which is generic in nature. All right, like active learning. How do you adapt active learning to your discipline? All right, what type of active learning strategy works best for the subject that you are teaching? All right, so that is the idea, general idea behind pedagogical content knowledge. So academic mentor is a unique breed of individual who knows pedagogy and who knows technical content. All right, you may find the terms engineering educator. Engineering educator is commonly used in the literature. All right, engineering educator, that's what we are. So emphasis on professional development, continual improvement. All right. So this is a model that I use, Jamison and Lofman. All right. So you question your teaching practice. All right. You look at your educational practice. You question them. Is this effective? Or you read about it. Flipped classroom. How is it like? Okay. Is it going to work for my student? You carry out education research. All right. You collect data from the students' learning. Talk to them. Interview them. Look at their answers that they have submitted after you make the change. All right. Any insights that you get? Reflective practice. What are insights you get? All right. Improve your practice. So you can see that again is based on the quality assurance cycle, quality improvement, continual improvement cycle. Right. So that is the framework. I'll leave you with that. Okay. If you want to read more, all right, you can go to the CDIO website. I presented my work last year in China. Right. The papers are there. You can, because there are many more papers in the CDIO website, but if you want them directly, you can always write to me. Okay. So I talk about what are the innovation in CDIO. Oops, sorry. What is the innovation in CDIO and how I use this to mentor another academic mentor in training. And lastly, all right, I know my time is most up. All right, Mr. Lee there, he's going to throw the other mic at me. All right, so timeline, 1 year. Remember, it's a 1 year program. So in this case, all right, the semester is implemented, all right, in April 2015 for my colleague, but the work started way earlier. You see, 1 year in September. All right, we carry out our project.
This is a very interesting scheme.
So we revise the material. When the semester starts, we teach it. We teach together. Me and a mentor, we teach different classes of students. All right, and every 2 weeks we meet and discuss how the teaching goes, what improvement we need to make. So this is a co-teaching. Oops, I'm so sorry. What happened? I'm too excited. What do you stop me? Is it? Okay. All right. Yeah, it works. All right. Okay. The last item. Okay. So I'll just stick to this. All right. So as I said, there will be regular meetings every 2 weeks. We sit down and discuss what is the challenges that she faced, which part of the pedagogy she doesn't quite understand. All right. So we do that and we evaluate the results at the end of the semester. Right. So that becomes the basis of the paper that I shared in China last year. And this research is still ongoing. All right. I just came back from Finland 1 week ago presenting an updated work. And later part, I'm going to Japan to do another presentation on the work done. It's on flipped classroom. All right. Anyway, so that's all. All right. I better give my mic to Mr. Lee here.
Right. Give a round of applause to Mr. Chia for his sharing. Thank you. Okay, what are we going to do next? Remember I shared with you the importance of assessment? Now we're going to have assessment. It's real. The only good thing is open book. Okay, it's an open book assessment. And we're going to share, my colleagues will be passing the test paper to you. It's very easy, okay? We expect everyone to pass easily. Okay, maybe you can help me to distribute. Okay, my colleague here will help me to distribute. Each one take a copy. You can take your notes. It's an open book. All right. There are 2 segments. The first section is true or false. True or false. 50-50 chance. Okay. The second segment is fill in the blank. Fill in the blank with your notes open. Okay. So please open to the one on Open to the page that will show you the 4 phases. The Advancing CDIO Integrated Canvas. Ah. 19 page 19 I learned a little bit. Okay, can you please take a look? All right, you should be able to do it in 15 minutes. No paper? More paper? Where are the test paper? Who has extra?